All right, so this is no particular problem out of the book, but I wanted to do an example here where we got to use the tool, or the power of the tool, a little bit more. So in this particular problem, we have a couple of differences from our parent function. One, we have an amplitude that is equal to 3, not 1. And then we also see that we're having a change, something that's going to affect all of our inputs. They're all going to be multiplied by 2. Now, the first piece is to figure out our y values. Now, we can figure out our y values by first determining a, which we know, and then also by determining what, or if there's anything added to our function here. As you can see, if we're adding anything, it's 0, so that d that's over here is just going to be 0. Now, I made these generic, so I do actually need to change this here. We're dealing with cosine in this particular problem. And we can see here that since a equals 3, and I'm multiplying all these values by 3, I'm going to go ahead and just write those in here right off the bat. 3 times, 3 times, 3 times. Okay? Now, what I need to do is I need to fill in what it's times. Now, it's going to be 3 times cosine of 0. Hopefully you know cosine of 0 is just 1. 3 times the cosine of pi over 2, which is just going to be 0 times 0. Now we have cosine of pi is negative 1. Cosine of 3 pi over 2 is just 0. And cosine of 2 pi is 1 again. Okay, and that's going to be one full cycle through. Now, to determine our new angles or our new critical values, what we're going to need to do is we're going to have to figure out how to change 2x into our parent function, x. Well, hopefully you guessed that we can just multiply by 1/2. If you decided that we should divide by 2, that's the same thing. I've found, though, that multiplying by 1/2 tends to make a little more sense since we're dealing with fractions here. So 2x times 1/2 would give us x, so we're going to multiply all of our original special angles from the unit circle. We're going to multiply those times 1/2 as well. Okay. Now, we multiply those out, and we're going to get our new critical values. So the critical x values here, 0 times 1/2 is just 0. Pi over 2 times 1/2 will give us pi over 4. Pi times 1/2 is going to be pi over 2. 3 pi times 1/2 is just 3 pi over 4. And 2 pi times 1/2 gives us pi. So now we can see that our period is going to stretch from 0 to pi. Therefore, our period must be pi. Pi minus 0, which is equal to pi. And again, you can get that period by subtracting the first new critical value from the last one. That's how long it takes to go through one full cycle. Now, our y values, we're just going to transfer over from the first column. So 3 times 1 gives us 3. 3 times 0 gives us 0. 3 times negative 1 gives us negative 3. 3 times 0 is 0. And 3 times 1 is 3. Meaning that we just took our original amplitude and we made it 3 times bigger in all cases. Or and it's not always bigger, especially in the case of the negative, but we stretched it basically 3 times in either direction, positive or negative. Now we're going to go over to our graph and fill everything in. So now we have our points. So we just start with the first one, 0, 3. 0, and then we're going to go all the way up to 3 here. And then, and in fact, I'm actually going to change these a little bit because it's going to get a little ridiculous. So let's go ahead and make this 3 instead. I think that'll work a lot better. All right, and this will be negative 3 here. Okay. I'm going to move it up here a little bit. So we're going to go up to 0, 3. Right there at 0, 3. Now our next point is right here at pi over 4, and we're down at 0. Then we go to then we go to pi over 2, and we're down at -3. Then we go to 3 pi over 4, and we're back at 0. Then we go to pi, and we're back at 3 again. Now we go ahead and draw our curve. Okay, and it should look something like that. Now, as we had mentioned, this is in fact one period. Okay? They wanted us to do 2 periods, so we have an option here, and actually I'm going to go ahead and do 3 periods, so we have a pretty nice example. Now, I noticed that, and this is why I wrote out my axis for this, with my new critical values, they increase by pi over 4 for each one of the ones that I have. So that means that if I start here and I make this basically my new 0, then this would be pi over 4, this would be pi over 2, 3 pi over 4, and pi. Similar to coterminal angles. Okay? Not quite, but close. Okay? So basically what I can say is, well, I'm going to start here, and I know that at 0, and again, this is my new 0, I'm at 3. Then when I move over pi over 4, I'm going to be down at 0. Move over pi over 2, and I'm going to be down at -3. Move over to or another pi over 4, and I'm at 0 again. And then I move over one more, and again, pi, I just traveled exactly pi. Pi to 2 pi is pi radians. I'm going to be up at 3 again. Okay. Now we can also do another period here over on the other end. Now, I kind of gave it away by saying that I was only going to negative pi, but we do know that we go through a cycle every pi. So if we end a cycle here at 0, then we're going to need to backtrack pi radians, okay, so that we have enough room to go through one, or exactly one full cycle. So at 0, and again, this is basically going to be my new 0, I am at I'm at 3, so I'm going to go up to 3. Then I go over pi over 4, and I'm at 0. I go over another pi over 4, and I'm at -3. I go over another pi over 4, and I'm going to be at 0. And then I go over one more pi over 4, and I'm back to my starting point. And as you can see, what basically happened is we were able to get through twice as many cycles as we normally would. Okay? So it basically takes us half as long, okay, to go through a cycle. Right? And that would be an example of how to draw 3 cycles using the tool that we have here.